Welcome to this further maths online revision session for AQA FP1, in which we will be considering the January 2010 question 4 on the topic of matrices. You can see we're given a matrix A in the form 1, 4, 3, 1, and we're reminded that I is the identity matrix. You remember the identity matrix for a 2 by 2 is 1, 0, 0, 1. And in the first part we're being asked to show that if you calculate A minus I squared, it's equal to some multiple of I. And we've got to find out what that value of K is to show that. So, if we start with the A minus I squared, we firstly got to take I away from A. So we're taking the 1, 0, 0, 1. So we're taking 1 off each of the diagonal values here and here, and 0 away, which won't make a lot of difference. And so this will just become the matrix 0, 4, 3, 0. And we've got to square that matrix, so we know we've got to multiply it by itself. So if we do that, remember it's row times column, so 0 times 0, 3 times 4 gives you an answer of 12, and that's the first row, first column, and there, so that goes in the first row, first column. Next one then becomes that next row by the same column, so it's 3 times 0, 0 times 3, both of which are 0, and adds up to 0. Then we'll repeat both rows with the second column, so it's 0 times 4, 4 times 0, so again both zeros, so that totals 0. And then finally we've got the second row with the second column, which is why this goes in the second row and the second column, so it's 3 times 4, 0 times 0, so that will give us 12. And we can see this is just like 1, 0, 0, 1, but of course it's 12 lots of it, so we can write this down as being 12 lots of I. Okay, so for somewhere having used the fact that I is 1, 0, 0, 1, we will get 1 mark. For then working out A minus I all squared and an attempt at it, with at most 1 numerical error, gives us a method mark. And then finally, for obtaining the 12i, we will get an accuracy mark in that part. Part B, we're then told that a matrix B is of the form 1, 3, P1, where P is some value. And we're told that A minus B squared is equal to A minus I squared. And if you remember, we've just worked out the fact that A minus I squared is 12 lots of I. So in other words, A minus B squared has to be equal to 12 lots of I. So, starting again on the left hand side, first thing to do is work out A minus B. If you remember, matrix A was 1, 4, 3, 1. So when we take this away, we can see we've got 1 minus a 1 and a 4 minus a 3. So that will give us a 0 here and a 0 here, because they're both taking away 1s. And then we're taking 3 away from 4, so that's 1. And then in here, we're going to get 3 minus whatever P is. Okay, so that's what the matrix A minus B is. Having got that matrix, we can now square that matrix. So in other words, we've got to multiply that matrix by itself once again. And so if we start to do that, we've got 0, again row times column, 0 times 0, 1 times 3 minus p, which will just give us 3 minus p. Do the next row with that, and we get 0 times the 3 minus p and 0 times the 3 minus p, so that's just 0. Similarly then, we do the top row with the second column, so it's 1 times 0 and 0 times 1, so that adds up to not a lot. And then finally we got the second row with that column, and that gives us a 3 minus p in here. And so if that's going to equal 12i, which was our answer from part A, then the value of p that we will have to substitute to make that true would have to be negative 9. Because remember, it's 3, take away a negative 9, so that's 3 plus 9, which gives us our 12. Okay, so we've got 4 marks again for this part. So for stating what A minus B is, will give us 1 mark. And then an attempt at squaring out the A minus B squared and obtaining a correct expression, the 3 minus p, 0, 3 minus p, will give us 1 accuracy mark, and then finally an accuracy mark for obtaining the correct value of p to show, or to complete the question as required. Hopefully you found that solution helpful. For more work to help you with your maths revision, please go to the Further Maths Support Programme website.